So hello dear students, here the question you are watching at your screen is an ultimate combination of limit of sum Newton-Leibniz and L'Hopital rule. So let's check it out. So what do we have? We have got this sum 1 plus 1 by 2 up to 1 by n. So we're gonna write this as a summation. So this is a summation of 1 by 2, 1 by 3, 1 by n. So we're gonna write it that r is running from 1 to n and 1 by r, summation of 1 by r, n tending to infinity. The limit is there, and we're going to write this in denominator for the time being, just to show you all that what the question actually is. But in the latter part of the question, we're going to solve this numerator part only. So let's just take the numerator part because that's where the complication lies. We need to deal with the numerator part first. So the numerator is limit n tending to infinity, r from 1 to n and 1 by r. So what do we do? Well, let's just multiply and divide the whole thing by n. This 1 by n is staying outside and that n goes inside and gets multiplied. So 1 by n is here, limit n tending to infinity is also here, this summation is also here, the lower limit is 1 and upper limit is n. This 1 by r by n, we're gonna write this n by r as reciprocal of r by n for the very reason that we convert it in the limit of a something. This 1 by n will become dx. Obviously this summation will become integral. This r by n becomes x, so we're gonna write 1 by x. And this upper limit and lower limit, what do we decide? How can we decide that? We put a limit n tending to infinity and n by n 1. So undoubtedly that upper limit is 1, but while we are placing the lower limit, in general we write 1 by n, limit n tending to infinity is 0, but for this we are not supposed to write this, so we're gonna simply put 1 by n because we need to keep this limit alive. If we put 1 by n equal to 0, this limit gonna die, so in the latter part we won't be able to apply this limit thing. So to keep this limit alive and active, we must write this as just 1 by n. This is log the denominator wala part. Now this is, if you check that this 1 by n, the integration wala mein 1 by n is 0, so 0 se 1 is log, so this comes infinity by infinity. So infinity by infinity form LH rule. So we're gonna differentiate the numerator and denominator. So upon differentiating and applying Newton-Leibniz, 1 0 and this minus 1 by n into minus 1 by n square, that's 1 by n's derivative. And in the numerator part, we're gonna write simply log's derivative is 1 upon 1 by n plus 2. And now upon simplifying, just a small simplifications are needed. Minus of 1 by n and minus 1 by n square, we're gonna multiply the numerator part, and in the denominator we have 1 by n plus 2, that's not a problematic. So now upon further simplifying, we got n by n square, and this denominator thing will go upside down, so it will get multiplied by the numerator n plus 2, this will get cancelled out. Now we are left with n plus 2 by n. So n plus 2 by n, obviously upon splitting we get 1 plus 2 by n, which will tend to 0, and now our answer is 1.